Oh, Ralph, how I envy your optimism. There is no Springfield 50 years in the future. With global warming trapping the CO2 inside our poisonous atmosphere, our superheated oceans will rise, drowning our lowlands, leaving what's left of humanity baking in deserts that once fed the world. And in the new Nineveh, darkness falls.
So the first half of my talk is all about the existential threat of climate change, and then I'm going to talk about the structure of the climate debate. My name is Richard Toll. I teach at the moment only in the third year, Environment and Climate. By the time that you get there, we may have switched part of it to year 2, but you won't see me for at least 1.5 years. I'm going to talk about climate as an existential threat. Can we have silence, please? Also going to talk about actual estimates of climate change. Going to talk about the reasons why people portray problems differently than they are. I'm going to talk about climate policy and a little bit about its cost, and I'm going to conclude with the state of the climate debate. But as I said, the first half of my talk is really inspired by Extinction Rebellion, and one of their posters you see here. And I'm going to take this literally. We are at a university, so we are allowed to be pedantic. In fact, we are required to be pedantic, and that's what I'm going to do. The lady you see here claimed that she literally died. I think that she looks very good for a zombie. Literally means that it's literal, that this is what you mean, what you say. I know that nowadays in English, literally means is a form of emphasis, but I'm going to take this literally. I'm going to start with...
shitting themselves about what's happening for the future. They've got another 50, 60, 70 years to live on this planet. By that time, there could be only 1 billion people left. I mean, that's 6 billion people that have died from starvation or being slaughtered in war.
The founder, or one of the founders of Extinction Rebellion, takes this threat literally. Right? He claims that billions of people will die because of climate change. And this is a common thing that you see. You often see it during protests. You'll die of old age, I'll die of climate change. It's not just Roger Hallam and the guy you saw in the protest, it's also Leonardo DiCaprio, right? The famous actor. If we do not act together, we will surely perish. If you do not believe actors, maybe you believe David Attenborough, who claims that a collapse of civilization is on the horizon, a collapse of civilization because of climate change. Christine Lagarde, when she was director of the International Monetary Fund, said that unless we take action on climate change, future generations will be roasted, toasted, fried and grilled. She is now the head of the European Central Bank. They are not alone. There's other people who say this, Ban Ki-moon, Emmanuel Macron, Angela Merkel, Desmond Tutu, Barack Obama, all said very similar sentiments. Of course, not everybody is with them. This is the current leader of the House of Commons, who actually doesn't think that climate change is the biggest problem of humankind. It's the silencing of Big Ben that is really the biggest problem of our times. But Rees-Mogg is alone, almost alone on this. This is Bill Nye, the science guy. If you've been to the US, you would have seen him on telly, talking about climate change with a picture of the globe on fire. Now, I don't think that Bill meant this literally, but Greta Thunberg, who you no doubt have heard of, does seem to take this literally. I don't want your hope, I don't want you to be hopeful, I want you to panic. Act as if the house was on fire. And it's not just activists, it's also politicians. Here's another favorite.
And people, and Gen Z and all these folks that come after us are looking up, and we're like, the world is going to end in 12 years if we don't address climate change. And your biggest issue is, your biggest issue is, how are we going to pay for it? Millennial.
How we deal with climate change, which, as you indicated, is an existential threat to the planet.
That is an existential threat to a planet, right? So there's people out there, I mean, I started with Roger Hallam saying that 6 billion people will die. We ended with the destruction of the planet, right? That is the current discourse about climate change. And you often see headlines like these, 100 days to save the world. And we're now in the run-up to Glasgow, which will start in 6 days, if I'm not mistaken. The 26th conference of the parties to the United Nations Conference, United Nations something on climate change, I forget what this first C stands for, that we only have so much time to save the world. This is an expression that is very common, because if you look at the small numbers here, this was actually written in 2015 in the run-up to another climate conference. And this is not a new sentiment, that the world is about to end and we only have a short time to save it.
You should just come over. We had 5 years of deciding. You sky wept when he told us Earth was really dying. 5 years, that's all we got. We got 5 years.
For those of you who are not familiar with your music history, this is David Bowie, of course. For those of you who are not familiar with fashion industry, this was the early 70s, right? So it's not at all a new sentiment at all. And there's a widespread belief that climate change will indeed be the end of humanity, that it's literally an existential threat to our survival. The survey results that you see here are a few years ago. What do people believe climate change will do to them? The different colors are in sort of purplish Asian and Pacific country, then pinkish Middle East, and in green European countries and the USA. Will climate do serious damage to the economy? Almost universal agreement. Cities being lost to sea level rise, small wars being caused, a new world war being caused because of climate change. But also, if you look at the bottom one, extinction of the human race, that is, no more Homo sapiens, goes up to 75%, 80% in some countries. But even in the lowest, in the most optimistic country, it's more than 25% of people believe, well, if we take these results at face value, believe that climate change really means the end of us, right? I will die of old age, I'm a lot older than you are, you will die of climate change. I'm not gonna talk about all these claims because I only have 1.5, 2 hours, but I'm gonna review 3 of these claims. That is, we're all gonna drown, we're all gonna starve, and we're all gonna fry, right? Going back to what Christine Lagarde, the current head of the ECB, said. I'm going to start with we're all going to drown. This is the North Sea and the countries around the North Sea as they look now. This is with 1 meter sea level rise. This is with 5 meter sea level rise. And this is with 50 meter sea level rise. We're all going to drown, right? Another way of depicting this, and this is a picture from the New York Times, if I'm not mistaken, shows where are the countries, or the cities of the world relative to sea level. Venice, Los Angeles, Amsterdam, pretty low lying. Hamburg, St. Petersburg, lower. Slightly higher, but still pretty low. San Francisco, South London is underwater. Shanghai, Edinburgh, New Orleans, New York, London, the whole of London, Taiwan. And this is a fairly dramatic picture. All these cities will be flooded. And if you don't like this sort of picture, maybe you can see this one. This is how the world map would look like in 8,000 years. If you don't like this sort of pictures, that's sort of like information diagrams. There's also the more dramatic pictures, like a lot of the world's monuments being washed away by the sea. You see the Eiffel Tower and the Statue of Liberty. This is from the Worldwide Fund for Nature. Stop climate change before it changes you. Apparently it's gonna metamorphose into something that looks a bit like a human and a bit like a fish. And of course cultural icons will also be washed away by the sea. This is George, Ringo, John, and Paul. But the thing that people are completely missing when they draw up these pictures is the time scale. What you're looking at here is the evolution in the past and projections of the future of sea level rise. And it looks quite dramatic. We start 20,000 years ago. This was a graph that was drawn up by geoscientists who are a bit nuts. They think they sort of turn the timeline on its head. So 20,000 is 20,000 years in the past, and then minus 10,000 is 10,000 years into the future. As I said, they are a bit strange. But time runs at least from left to right. And this is historical sea level rise. At the end of the Ice Age, a lot of ice was stored in ice caps. A lot of water was stored in ice caps. That has all melted and raised the level of the sea quite dramatically, well more than 100 meters. And then this is where we are today. And then in the future, more and more water will be added. And it looks quite dramatic. And it can be up to 50 meters of sea level rise. And that is if Greenland melts, if West Antarctica slides into sea, and if East Antarctica melts. And if you then add on top of that the thermal expansion of the ocean water, you are indeed talking about 50 meters of sea level rise global average. But because particularly the South Pole is so heavy, the ice cap is so large, it actually has a gravitational pull on the water, that if that pull is no longer there, if the East Antarctic ice sheet melts, then water will redistribute over the planet, and that 50 meters on average over the planet will be 70 to 80 meters in Europe. Because actually the South Pole pulls away about 20 meters of water away from us. Which sounds very dramatic, right? 70 meters of sea level rise, then it's indeed bye-bye London. But the question is, what is the time scale? We're here talking about 10,000 years. I'm going to blow it up. What is happening during this millennium? You see that actually by the end of your lifetime, and I think most of you guys will see the year 2100. I won't, but you will. We are 2100 is around here. We are talking about 50 meters of sea level rise. Now, I was complaining before that this desk is so low, it's made for dwarves. It doesn't help me wanting to talk into a camera. This is more than 50 centimeters high, right? 50 centimeters is not a whole lot. And it's 50 centimeters over 80 years, over 100 years. That's a tiny little bit per year, right? So that is not a big sea level rise. And even if you're talking about not at the end of this century, but the end of your lifetime, but at the end of the millennium, so that's at the end of the lifetime of your great-great-great-great-great-great-great-great-grandchildren, it will be only 7 meters, right? And that's the max if everything goes wrong. So the pictures that you see of all the cities in the world flooded, not in this century, not in this millennium, right? This is something that is in the far, far, far future, when we don't know what the world will be look like. Current projections are that there will be far fewer people at the end of the century than there are now. And definitely in the end of the millennium, there will be far fewer people because we have fewer and fewer children. So the idea that we cannot accommodate, perhaps in 10,000 years' time, 50 meters of sea level rise strikes me as a bit of a far-fetched conclusion. But there is more. Another thing that people often worry about, but what about small island states? Well, what about them? What you're looking at here are two satellite pictures of Hulul Male, which is the island next to Male. It's the island next to the capital of the Maldives. And it's actually where the airport of the Maldives are. And these two pictures were taken 20 years apart. And you see that the top picture is complete devastation, right? There's the landing strip and that's it. Then this picture, completely built up, residential areas, industrial areas. 20 years' time, this can happen to an island, right? What I did not say is that this is 2017 and this is 1997. These are not the impacts of sea level rise, these are the impacts of development. And the people of the Maldives, even though they don't want you to believe this, they want you to believe that they are very, very vulnerable to sea level rise so that they can get more development aid and all sorts of goodies and all sorts of support. They're actually very good at coastal protection nowadays. So good that they can take a fairly devastated or nothing there at all and turn it into a highly developed industrial and residential zone. And the Maldives are actually doing fine, mostly selling financial services. And of course, the basic technology here, dike building, that helps protect us against sea level rise, was invented, we actually don't know when, but we do know that the ancient Sumerians, 5,000 years ago, and the ancient Chinese, and the ancient Egyptians, and the ancient Babylonians, all knew how to do this, right? Of course, nowadays we are much better at coastal protection, much better at dike building than the guys and girls were 5,000 years ago. But we know how to protect our coasts, right? Recently we had a big storm over New Orleans, and some of you may recall from your earlier youth that there was a big storm, Katrina, that devastated New Orleans with 18,000 people killed, 1,800 people killed, don't overdo it, and almost all of the city underwater and 3/4 of the population of the city evacuated. Now, a couple of weeks ago, a very similar storm hit New Orleans. But there was no loss of life, there was no major flooding. Why? Because that 1993 storm, Katrina, scared them so much that they actually start taking coastal protection seriously. And by now, levees and seawalls and everything protect New Orleans. And a similar storm happened a few weeks ago, as I said, with no major damage. We are very good at protecting ourselves against floods and storms. The next question, the next assertion is that we're all going to starve because of climate change. There will be no more food in the future, which is an essential problem, right? If you don't eat, then 2 weeks later you are dead. And some of you will die before that, right? Those of you who are not so healthy. Now, what do the models actually tell us? What you're looking at here is a whole bunch of results. A whole bunch of results from the Intergovernmental Panel on Climate Change. This is a review of all the studies of what would climate change do to crops. And there's 12 different results here. What we're looking at are maize, wheat, and rice. These are the main crops. This is where we get our calories from these three crops, essentially. We're looking at the impacts in the temperate regions where we are and in tropical regions. Then on the vertical axis, you're looking at the yield change. That is, how much grain do we get from an acre of land. And then on the horizontal axis, we're looking at an indicator of climate change, namely local warming. So that is what you're looking at. And then in blue, you're looking at studies with adaptation, and in red, you're looking at studies without adaptation. So we have 12 sets of results. So now what do you see here? Let's focus on the red, and that is what you typically see in the media. And indeed, what you find is yield declines of up to 50%, 60% even. Oh my God, we're all going to starve, right? If you take away 60% of our food, I mean, we waste roughly 30% of our food, but if you take away 60% of the food, then indeed we have a major supply problem. But you also see that these are actually a little bit of outliers. And the central estimates, and that is what you see in the solid lines, are much less pessimistic. So the things that you read in the newspapers of up to a 50% loss in agricultural output, that's not the median study. That is the most extreme study, right? That is what the word up to means. And that does not mean that that will happen, right? This is just the most pessimistic scenario, and perhaps the least well calibrated scenario. What you also see is that if we focus actually on heat-loving crops, like rice, I mean, wheat is a cold-loving crop. So if it gets warmer, wheat is in trouble, because wheat likes it cold. But if you look at rice actually likes it hot. And a hotter planet actually is good for rice. So yes, climate change will have impacts on food production and will have impacts on your diet, in the sense that bread will become more expensive and rice will become less expensive. The final thing I want to say about this is the difference between the red and the blue. In red, the assumption is that farmers are going to do what they have always done and will continue to do so. They will plant the same crops at the same time, irrigate them the same way as they always have done, apply the same sort of fertilizers and apply the same sort of pesticides as they have always done, and then they will harvest at the time that they have always harvested. This is a very strange assumption, because the assumption here is that the farmers see their crops fail and they're not going to change their behavior to see whether something else perhaps works better. No, they keep on doing it. And even if their crops fail year after year after year after year, they will continue to do the same thing. If you ever meet such a farmer, please tell me. In blue, the assumption is for very limited on-farm adaptations, that farmers will change the planting date and will change the harvest date and will change irrigation without actually major investments, new investments in irrigation. And what you then see is that a lot of the negative impacts are taken away. And we're talking about fairly mild effects on the food supply. There's another thing going on, and that is, if you look at what happened historically to crop production, and we're now looking at the US, a whole bunch of crops starting around the year 1900 going to the year 2020, and it's again yield, so how much potatoes, how many potatoes, how much rapeseed, and so on and so forth you get, and so on and so forth, you get from an acre of land. And you see that this has gone steadily up. This is technological progress in the agricultural sector. This is new pesticides, new fertilizers, better plowing techniques, and so on and so forth. There is absolutely no reason to assume that this trend will not continue into the future. And what we have seen is a 6-fold, 8-fold increase in yields over the century. And if this trend continues into the next century, even if you take away half, we still grow 4 times as much crops as we do today, right? And the story doesn't stop here. This is the so-called yield gap. And the yield gap is the difference, or rather the ratio of what the average farmer gets of her land and what a model farmer gets. So in all countries in the world, there's model farms that sort of like show farmers, tell farmers how to do. They do a lot of experiments. This is how you best grow your crops. And this is current current technology. I should not have done that. I got something stuck in my throat, sorry. This is current technology. This is on the current climate and on current soils. So that is what the model farm gets in potatoes and in rice and in wheat and what have you, versus what your standard, your average farmer gets. And in Europe, what you see is that the yield gap is close to zero, right? Your average farmer gets the same as the state, almost the same as the state-of-the-art farmer. If you move to particularly parts of Africa, and this is Angola, right? The yield gap can be up to 80 or 90%. The average farmer gets only 10% of what a model farm, working on the same soil in the same climate with state-of-the-art technologies get. Right? It's a factor 10 difference. So if we can move these farmers from their current pretty substandard techniques just to the state-of-the-art, you increase yields by a factor 5, maybe more. If climate change takes away half of that, you're still 2.5 times better off, right? So we're not all going to starve because of climate change, right? It's simply not in the data. Final claim, we're all going to fry. This is the number of days projected to exceed potentially deadly heat levels for the year 2100. And this looks scary. And heat kills. We are warm-blooded animals. We need to keep our inner body temperature at around 37 degrees. If it goes 2 degrees below that or 2 degrees above that, maybe 3 or 4 degrees above that, you die, right? Your organs will fail and you will be dead pretty soon. You probably heard of Death Valley. The reason Death Valley is called Death Valley is because if you spend too much time in Death Valley, you will die. At 55 degrees dry heat, your body starts to decompose, right? Your cells start falling apart, literally. And if you spend more than a couple of hours in such a temperature, you will indeed be dead. Now that is dry heat. Our cooling system actually works through evaporation, right? We sweat, we evaporate water, that cools our body down. So if it's very humid, it's actually much harder to evaporate water because the air is saturated with water already. That's what the word humid means. The critical temperature is actually around 35 degrees with 100% humidity Celsius. So this seems plausible, right? That in a hotter future, indeed, temperatures will be deadly to humans. And fairly deadly, right? In the very dark red that you see here, the Congo, right? Congo, sorry. It may exceed these temperatures 250 days a year. So this becomes completely unlivable, right? Now this is a model projection for the year 2100. If you actually read the paper, then the same model predicted that this year 30% of the world's human population is exposed to such deadly conditions. Now, we've had a lot of people dying from COVID, but it was not 30% of the world population. We have a model here that predicts in the past that 30% of the world population died of heat exposure. Right? That is a third of all your friends and family. That did obviously not happen to you. This is a headline earlier this year from the Telegraph where these temperatures were actually exceeded in Jacobabad, that is in Pakistan. And the journalist was a bit surprised, right? So he went to this city and the models predicted that everybody in Jacobabad should be dead, would be dead, right? Not should, that sort of implies that I want them to be. And he found all these people there going about their business, trying to keep cool but not dying, right? So this should be taken with a grain of salt. And there is, of course, other things that are going on. These are the sales of residential air conditioners in the year 2016. And you see indeed now that China is fairly rich. And China can get very hot in summer, even as far north as Beijing. If you travel through China nowadays, you see air conditioners everywhere. Picking up in India as well, particularly the middle classes in India now typically live in an air-conditioned home. A Future projections of this rely on these sort of pictures where they plot the relationship between temperature, that is in color, the redder it is, the hotter it is. Blue means cold, red means hot. Penetration of air conditioning as a function of per capita income. And what you see is indeed that as people grow richer, one of the first things they do, if you live in a hot country, is buy an air conditioner. That is true today. Projections in the future is that this will continue everywhere across the world. So, is climate change an existential threat? No. There is nothing in the literature that suggests human extinction or even large-scale mortality or even, for that matter, medium-scale mortality. The reason for this is very simple. If you look at where are humans, the answer is they are everywhere. We live on the poles and we live on the equator. We live in the rainforest and we live in the desert. Also, as a species, we've made it through 4 ice ages. And in all 4 ice ages, our technology was far inferior to the technology that we have available now. The idea that we are not, we're the ultimate generalist. If you compare us to any other species, we are much more widespread. We live in basically every climate on the planet. And it's not just that we are very well able to adapt ourselves to our environment, but we're also very well able to adapt our environment to us, right? Now, this is not to say that climate change is not a problem. It's just not an existential threat. That's just nonsense. What you're looking at here are estimates of the impacts of climate change on human welfare. This is a complicated graph. Let me tell you what is on here. On the horizontal axis, we're looking at scenarios of climate change here indexed by the change in the global mean surface air temperature, where 0 was the year 1750. We are now here somewhere. And the further to your right you get, the more serious climate change becomes, or the more profound climate change becomes. On the vertical axis, you're looking at the Higgsian equivalent variation, which is not a term you've heard before. Essentially, this means, this should be read as follows. If climate change, if the world warms by 2.5 degrees, that makes you feel as if you've lost 1.3% of your income. That is the Higgsian equivalent variation. So losing part of your income obviously would make you feel bad. Climate change also makes you feel bad, and the Higgsian equivalent variation allows you to directly compare these two welfare losses. The blue dots that you're looking at are the 27 studies that were published before 2018. There's a few more that have been published that I've yet to add to the graph. And then the red curve is a Bayesian model average across that. Go ahead.
How do you calculate the y-axis? Like, how would you quantify that value? So if your temperature lowers, you say you're losing, it feels like you're losing income. How would you actually work that out?
So the question is, where do these blue dots come from? How would you actually estimate this? Well, the most popular method, essentially what you do is you list all the impacts of climate change. And one impact is the impact on agriculture. So wheat yields would fall, rice yields would go up. You price that, sea levels would rise, so you lose land, you can price that, or you build dikes and you can price that, and so on and so forth. You do that for every impact. There's also a lot of impacts that are not traded on markets. I mean, if you're talking about wheat yields, you can just look up what do you pay for a bushel of wheat, right? But there's also health risks. So there you need to use special valuation techniques to come up with what is the value of an illness and what is the value of a premature death. If you're keen on learning how to do that, that is the topic of 3 weeks in environmental economics, that either the second half of year 2 or the first half of year 3. in the future. So that is what these numbers mean. Now, what do we learn from this graph? Well, the first thing is that we initially see positive effects of climate change. And there's 3 reasons for that. 1, CO2 is plant food. CO2 makes plants grow faster. CO2 is what plants eat together with water, right? Photosynthesis takes CO2 from the air and water from the ground and combines them into a carbohydrate that is a stem or a leaf or a root of a tree or a plant. And then as a waste product, because you have H2O and CO2, you need to get rid of the oxygen that you dump into the atmosphere. Oxygen to plant life is a waste product, right? We actually quite like oxygen, but it's a waste to them. So that is the first thing. More CO2 makes plants grow faster and also makes plants grow more, become more water efficient. Second, heating your home through winter costs money. So if that's warmer in winter, you save a lot of money on home heating. And chances are we will be drastically reminded of this coming winter, right? Because energy prices are so high. And the third effect is that, yes, it is true that heat stress kills. It is also true that cold kills. And again, we may see this winter. What happens during winter time is that people spend more time indoors, they spend closer together, and that means that all sorts of infectious diseases run rampant through the population. And in many countries, and particularly countries further closer to the poles, winter deaths are actually much higher than summer deaths, right? And part of that is simply a climate effect. So those are the 3 positive impacts of climate, the 3 main positive impacts of climate change. But, as I said, we are already hereabouts. The world has already warmed 1.2, 1.3 degrees. So the fact that the initial impacts of climate change are positive is actually irrelevant, because everything that will come in the future will have an incremental negative effect. And then such things as a drop in agricultural production, increasing demand for air conditioning in summer, which is also very costly, all sorts of other diseases may spread, sea level rise, and so on and so forth. Those will be the negative impacts that come about. The more pronounced the warming, the more negative the impacts. No surprises there. Experts actually roughly agree on the size of the problem. It's a few percent of GDP, right? But also an asymmetric uncertainty. So the central line, the fat red line in the middle, now I'm going way too fast. What is happening? Is the central estimate, and then this is the 70% confidence interval. And what you see is that negative surprises are actually much more likely than positive surprises. So the uncertainty is asymmetric, and it would actually make you more cautious. But the main message here is that, yes, these impacts have been quantified, and they're actually not that big, right? We're talking about a few percent of income, maybe 10% of your income. Climate change over a century would make you feel as if you have lost 10% of your income. But it is over an 80-year period, right? And the economy is growing by 2% per year. And if you accumulate that over a century or so, you are still much richer off at the end of the century. You are less rich than you would have been without climate change, but you are still much richer than you are today, right? Now, this is for the world average. If you look at the distribution of these impacts across the world, we actually get a different picture. So now we're looking at the impacts of climate change. It's still the Higgs equivalent variation, but on the horizontal axis we now have per capita income in the year 2015. And countries are essentially ranked from poor to rich. And what you see here, and this is all for the 2.5 degrees of warming scenario. And what you see here is that the impacts of climate change are concentrated in poorer countries, right? all the negative impacts are in the poor countries, and in richer countries you actually see much more positive impacts. Now there's 3 structural reasons for this. One is the structure of the economy. In poorer countries, a lot of people and a lot of economic activity is in agriculture, and therefore directly exposed to weather and climate. In richer countries, a lot of economic activity is in finance and in publishing and that sort of stuff, where you're basically indoors and shielded from weather and climate, right? So that is the first reason. The second reason is same information again, but now the horizontal axis has changed to the current temperature. Warmer countries are much more vulnerable to climate change than our colder countries. No surprises there. And of course, hotter countries tend to be poorer, and poorer countries tend to be hotter. Now, part of this is just a simple biophysical process. Part of this is also human adaptation. So if you wonder what will Brighton be like in the future, if we add 3 or 4 degrees to the temperature in Brighton, what will this city be like? You look at Barcelona, right? Barcelona is 4 degrees warmer than Brighton on average. And you wonder, how do people in Barcelona cope with this? Fairly well. I presume a fair number of you have been to Barcelona. People there seem reasonably happy and healthy and content. But they do things differently. In southern Spain, not so much in Catalonia. In southern Spain you see siestas, right? That you sleep during the heat of the day when it's bloody stupid to do something that involves physical activity. So you sleep during the heat of the day. What you do see in Barcelona is that people have dinner much later than we do in England, which is an adaptation to the climate, because actually digesting food heats up your body, so you should do that during the cool of night. What you also see if you go look at houses in Spain, houses here are badly designed to keep the heat in for winter time, whereas houses in Spain are designed to keep the heat out, right? And all these adaptations are there. And if you wonder what should we do with a 4 degrees warmer Brighton, the answer is be like Barcelona. And at the moment our football club is actually doing better than Barcelona, right? So that is all good. If you live on the warmest place on earth, in Jacobabad or in Dar es Salaam or something like that, or in Singapore, you can't look at how other cities have coped with this, because there are no hotter cities. And that means that you have to invent all these adaptations from scratch. It is much more difficult than just copying somebody else, right? The third reason has to do with adaptive capacity. I talked already about dike building as a protection against sea level rise. That costs money, right? Richer people have more money by definition than poorer people, so they can pay for that. It requires technology, right? You should be able to have access to the latest satellites and the latest models and the latest drag lines and what have you. And it requires organization. Right? We often complain about our incompetent government, who cannot get anything right. But if you compare the government in the UK to, say, the government in Nigeria, you're actually pretty well off, right? No matter how much of an idiot Boris Johnson may be, he is better than Buhari, right? Somebody is not quite sure of this, but I can assure you that that is true. And a lot of adaptation to climate change requires large-scale infrastructure, irrigation, coastal protection. The way to protect London in the future is to replace the Thames Barrier by a bigger Thames Barrier. That's a big infrastructure project. And that requires that the government is able to raise taxes to pay for this, and is able to actually make these decisions in a timely manner, and is actually able to pull this trick off. Whereas in many places, even if they are able to raise the money, somebody would steal it and stick it in a Swiss bank account, right? So poorer countries are worse organized. Now, where are we? What you're looking at is a picture of two Nobel laureates. Bill Nordhaus at the top showed in 1991 that the impact of climate change on human welfare seems modest, and that is still the consensus in the literature. Another Nobel laureate, Tom Schelling, writing in 1992, argued that the largest impacts of climate change are not so much impacts of climate change, but symptoms of underdevelopment and mismanagement. And the immediate implication is that there's two ways of avoiding these impacts. One is for greenhouse gas emission reduction, have less climate change in the future. The other is to have more development, right? And there's a real trade-off going on here. Now, returning to my theme, why do people believe that climate change is an existential threat, when obviously the academic literature says it's not? And I think this is millenarianism, and I always regret that I think that it is, because it's a difficult word to pronounce. Here we're looking at some headlines in the newspaper: disease, war, starvation, death. These are the four riders of the apocalypse, right? This is how the four riders of the apocalypse used to look like. This is what they nowadays look like. The old stories are the best. Not true. Good stories get old, right? And therefore the stories of times past that we still tell each other, those are the good stories, right? There were also lots of bad stories in the past, but they have fortunately been forgotten. So the old stories are the best. So if you have a message and you want to package that message for mass consumption, your best way of doing that is to cast it in a story that people are familiar with, in a story that people love, right? Journalists are not about telling news. Journalists are about selling newspapers, right? Environmentalists are sometimes about the environment, but environmental organizations are large organizations, and they need donations to keep themselves going. So environmental NGOs need to package a message in order to sell this to their donors and their members, right? And therefore it makes sense to package this in in apocalyptic terms. That's sells, apocalypse sells, right? Just like sex. And you can't sell climate change on sex, but you can sell it on the apocalypse. And politicians are egomaniacs, and they all like to be Bruce Willis, right? They like to be the one who saved the world. What better legacy for a politician than to claim you are saving the world? Right? So, where are we? I've argued that climate change is the smallest problem. How difficult and how expensive is it actually to solve climate change? You guys mind if you just keep on going and then end early? Or do you guys want to break? Keep going. Good. I like to be home on time. How difficult or expensive is it to solve climate change? There's two answers to this question. The first is, how would you do it, right? And the cheapest way to meet any target is to make sure that the marginal abatement costs are equal at the margin. This is a bit over your head still, but this is something that will pop up in micro time and time again. Equimarginal principles, right? So we want to cut our emissions. Suppose it costs you £10 to reduce your emissions by a ton, and it costs me £100 to cut my emissions by a ton. And we want to cut emissions by 2 tons. How are we going to do it? Are we going to each do a ton, then the total cost is 110? Or am I going to give you £10 and you're going to cut your emissions by 2 and I keep my emissions as they are, and then the total cost is £20, right? I have saved £100 by not doing it, so I can easily pay you £10, right? Is that a hand? No. It's very dark there, so somebody is doing things. So the cheapest way of reducing emissions is to have everybody pay the same for their emission reductions and the margins. And there's 2 ways of doing so. It can be a carbon tax, or it can be a system of tradable permits. Now, economists would argue that carbon taxes are better than tradable permits because of the following reasons. If you impose a carbon tax, if you make emissions more expensive, then people will start reducing their emissions. They will start using less energy and they will start using cleaner energy because you tax the emissions that come out of their tailpipe and out of their smoke pipe. But you don't know by how much, because you don't know everybody's price elasticity, right? But a good thing about the carbon tax is that even though you don't know what's going to happen with emissions, yeah, you have a guess, you have an estimate, but you don't know for certain. You have a pretty good idea of what the economic implications will be, because the economic implications are driven by the carbon price, by the tax, and that is something that you fully control, right? If you use tradable permits, you essentially set a cap on emissions. Unless you know everybody's price elasticity, you don't know what the price of those permits will be. So the good thing about tradable permits is that you know the environmental outcome, because that is the cap that you just set, right? So you know this for certain and you have it fully under your control, but you don't know what the price will be. And the question is, which of the 2 is worse? Price uncertainty or emissions uncertainty? And for a problem like climate change, price certainty is worth more. And the reason for this is that climate change is caused by the accumulation of CO2 over time and across the world. And that means that for a small part of the world and for a small period of time, it doesn't really matter how much you emit. It doesn't really matter how much the UK emits between 2 elections, because climate change depends on the accumulation over decades and centuries and what everybody in the whole world is doing. So the UK on its own can never, and definitely the UK between 2 elections, can never make a serious dent in climate change. That's just not how the problem is structured. And therefore your emission certainty doesn't really matter, because we cannot really affect the climate much. Your price certainty does matter, right? If you set your target too stringent, then the price can be very, very, very high. And we see that at the moment, or rather we saw it very recently in China, where the central government announced very stringent CO2 emission reduction targets. And China being China, a lot of the lower officials in municipal and provincial capitals said, we're going to meet those targets because Xi Jinping said we should, so that is what we're going to do. And what they did was, well, the big source of CO2 emissions is coal-fired power plants. So the cheapest way, the quickest way of cutting emissions, I should not say the cheapest, the quickest way of cutting emissions is to close your coal-fired power plants. The problem is, if you do that, they don't make electricity anymore. And China went through a couple of weeks of fairly severe blackouts with all sorts of industries having to shut down and so on and so forth, because there was no electricity. So they've quickly reversed that problem. But the moral here is that if you set too stringent a target, then you can have real economic costs for your economy, right? So price certainty is actually worth a lot, much more than emissions uncertainty. And therefore, what you should do, the way you should do climate policy is a carbon tax, a uniform carbon tax, and nothing but a carbon tax. Period. And then the carbon tax, again, an equimarginal principle, should increase over time with something akin to the interest rate. Now, what is this going to cost us? The first question is, of course, what is this, right? What you're looking at is a result from the Intergovernmental Panel on Climate, the Intergovernmental Panel on Climate Change, in its 5th assessment report. Methane emissions, carbon dioxide emissions. I cut off the top of the graph, 2030, 2050, 2100. And what you're looking at is the change compared to 2010. So this is where emissions should be in 2030. This is where emissions should be in 2050 relative to, by now, 11 years ago. And this is where emissions should be at the end of the century. And what you see is, okay, and then the scenario at the top has a fairly lenient climate target, a very lenient climate target. And then the ones at the bottom would get you roughly to the top end of the Paris targets. And what you see is fairly drastic emission reduction for those scenarios. And actually, what you see in the two most aggressive scenarios is that emissions should fall to 120% below what they were in 2100. That is, emissions should go negative. We should no longer put CO2 in the atmosphere. And it's not just enough to stop putting CO2 in the atmosphere, but we should actively remove CO2 from the atmosphere in order to meet the 2 degrees target. This is what this looks like over time. Yeah, it's actually running. Historical emissions here, and these are the positive emissions. We're hitting roughly 2 degrees by 2100. And you can cut emissions, you can make them negative, and that means that you have to work less hard in reducing your positive emissions. So there's two forms of negative emissions. One is to have a bioenergy plus carbon capture and storage. So you grow trees, as trees grow, they suck up CO2 from the atmosphere, then you cut them down, you throw them in a coal-fired power plant and burn them, but rather than emitting the CO2, you capture the CO2 from the flue stack and stick it underground or underwater, right? And then you have negative carbon energy. Alternatively, you can have artificial photosynthesis, where you just have a machine that sucks CO2 out of the atmosphere, right? With no positive gains, no electricity generated or anything. So this is what it would take to get us to 2 degrees. This is what is needed for 1.5 degrees. So this is the upper end of the lower end of the Paris targets. Does it start again? Yes, it does. So if we don't have negative emissions, we need to cut emissions basically to zero now, right? Turn off your computers, right? Walk home. Don't turn on the oven, don't turn on the heating. But if we allow for negative emissions in the future, these are mostly unproven technologies at scale, then you can still see just how dramatic the cut in emissions is, right? Compared to what they've done in the past. And it's not just that. A lot of our emissions are essentially set in stone. They come from long-lived infrastructure. So the CO2 comes from energy. Energy is driven by power plants. I've mentioned them a couple of times. A coal-fired power plant is a lifetime of 60 years, right? So the coal-fired power plants that are built today, and they're still being built today, will still be around in 2080, right? Cars have a lifetime of 20-25 years. So the new car that you buy today will retire, probably in Kenya, in 2040, right? And with that, all the emissions. Another important part of emissions is how we heat our buildings. And a lot of that has to do with the structural characteristics of your building. And we replace houses at a much lower rate than cars and other machinery, right? So a lot of this stuff is set in stone. And that is what you see here. Essentially what they've done is they took all the existing power plants and all the existing chemical facilities and all the existing cars and said, well, this is the remaining economic lifetime of these things. And this is their standard use. This is how much CO2 they emit in your average application of these things. And if we just take the existing infrastructure and we don't build anything new, we just take the existing cars and the existing buildings and the existing machinery and the existing power plants and what have you, then this is the CO2 that comes out, and then by source, and then here it is by country, where China is in red, right, fairly big. And if you do that, right, then you just blow through your budget for 1.5 degrees. You just can't get to 1.5 degrees without premature retirement of capital. The problem with premature retirement of capital is twofold. One, it is expensive because you build a new plant and then 2 years later people tell you you should shut it down, and you had counted on making money of it for 40 years, but after 2 years it's shut down, you lose your shirt, right? So it's expensive. Second, who is going to pay for this, right? Does the government of India have sufficient money to buy out its industry for the capital it's going to retire? No, right? It won't have that sort of money, and the only way to get that sort of money is to raise taxes, right? And then you have a revolt from your taxpayers. This is politically very unlikely that on a large scale we're going to prematurely retire capital, right? But if we move away from 1.5 degrees, which is just harebrained, I think, and focus on the less dramatic scenarios, this is what is going to happen. So these are the carbon prices needed to meet various targets, where the light blue is the upper end of the Paris target. This is the year 2020, it's already in the past. This is a study that was published a few years ago, 2030, 2050, 2100. And the carbon price is given here on the vertical axis. Now, a price measured in dollars per ton of CO2 doesn't mean anything to you, right? The current price in the EU ETS as well as in the UK ETS, the current price of carbon, is somewhat to the lower end here. This is where we are now in the most progressive part of the world. Actually, California is slightly below in its pricing, slightly below Europe. And if you look at the north east of the United States, it's lower still. If you look at the current price in China, it is lower still. And then in most of the world, the current price is actually zero. I pointed that China was here. China is actually more like here, and the same is true for Reggie. So we are not on track. There's a few parts of the world that are on track to have their carbon prices high enough. And this is 2030. Actually, what you see that between, this is a logarithmic scale, right? So we go from 20, 30, 40, 50, $60 per ton of CO2. We should go to 90 by the end of the decade, and we should go well above 100. So we actually should see fairly steep price inflation for carbon prices. Unless we are pessimistic, unless we believe the more pessimistic model, then we should actually see much steeper price inflation for the carbon price. So it's doable. It's not unimaginable that the price of carbon will go up. But the important thing to note here is that, the most progressive, the greenest parts of the planet are actually just getting there, And most of the world, only 25% of CO2 emissions at the moment is priced, right? So we are way below this, and we're actually on world average, we're more like here than here, right? We're far away from that. Now, what will it all cost? Here are projected consumption losses. Again, the answer is a few percent of GDP. Again, it depends on scenario, depends on the model, depends on the time you're looking at, but we are talking about an economic sacrifice. This is measured less than 10% of GDP, again smeared out over a century. So this is small fry, right? We are talking about a fairly small investment. And the reason for this is very simple. If you look at energy as a cost base, on a cost basis in the world economy, it's 2 or 3%. 2 or 3% of our total income we spend on energy, pure energy, on the fuels, not on all the transformation and all the services that come with energy, but just on the fuel itself. And if you look at current prices, wind and solar are barely more expensive than coal and gas. Say they're 10% more expensive. So if you take 2% of your cost basis and you raise that 2%, not by 10 percentage points, but by 10%, right? You spend 2.1% of your income. No, I said 10%, 2.2% of your income on this, right? That is not going to break the bank. That cannot break the bank, right? And actually the costs of renewables, of carbon-free energy, as well as actually the cost of carbon-free food, has fallen dramatically over the last 30 years, and it's still falling very rapidly. So this cannot break the bank, right? And that is what we see here. Yes, it's going to cost money because we are forced to do something. We're forced to phase out coal and oil and gas faster than we otherwise would have done. But we're going to phase this stuff out anyway because we're running out, and it's dirty and it's expensive, right? It's going to be relatively expensive in the future. So this is not going to break the bank. So I've now said two things. One, climate change is a small problem, and climate change has a simple solution and a cheap solution. This is not what you read in the newspapers, right? And I think you should ask yourself the question, what are we doing, right? What is all the fuss about? Why have we spent, well, not you guys, but how has the world spent more than 30, actually we started talking about international climate policy in 1985. 1985, I was in primary school. No, that's not true. I was in secondary school. Right? And we've been talking about climate change and international climate policy ever since. And we've seen dramatic headlines in the newspapers since the late 1980s. Right? Well before you were born. How can it be that we've made such a big problem of such a small problem? Now, there's 3 reasons for this, and I'll spend most of the time on the third reason. The first problem is that climate change is a global public good. Now, you don't know what a public good is yet. A public good is something that where the consumption is non-rival and non-excludable. Non-rival means that non-rival is best seen as a physical property. If I eat my ice cream, you cannot eat it because it's no longer there, right? I actually feel more like beer than ice cream at the moment. If I drink my beer, you cannot drink it. So that is a rival consumption. That beer is legally mine. I went to the bar and I paid for the beer. So before I have drunk it, it is mine and you may not drink it, right? Because that would be theft. And private goods are rival and excludable. Public goods are non-rival and non-excludable. And CO2 is both. If I reduce my CO2 emissions by cycling to work rather than driving, there is nothing you can do about it. You cannot forbid me to cycle, you cannot force me to drive, right? You have no legal recourse there, so it is non-excludable. It's also non-rival, because if I reduce my CO2 emissions, we will have a little bit less climate and we will all enjoy ourselves better. And my enjoyment of the weather does not affect your enjoyment of the weather, unless you happen to see me half naked frolicking in the park, right? But my enjoyment of a day at the beach does not affect your enjoyment at the day at the beach. So it's non-rival in consumption, right? And this is true at a global scale. And the implication of this is, and because CO2 spreads in the atmosphere, so if we emit CO2, within a couple of weeks it's all over the planet and it affects the climate everywhere. If we reduce our emissions, we face the costs of more expensive energy, more expensive food, but the benefits are shared between everybody on the planet. So it is always in our best interest if others reduce their emissions. It's always better if somebody else solves a global problem for you, right? So public goods are overconsumed and underprovided. And CO2 is a global public good. CO2 emission reduction is a global public good. CO2 is a public bad. Therefore, over provided public good is under provided. Now, in the sort of first half of international climate negotiations, from 1985, more 1995 to 2009 in Copenhagen, the international climate negotiations were all about internationally, legally binding targets and timetables, that countries would go into the negotiations and would come out not with a promise to do something, but with a legal obligation to do something, something that they were obliged to do under international law. And lo and behold, you can't do that, because every country argued, yes, we should cut emissions, or rather, yes, you should cut your emissions. I am innocent, right? For me it's too expensive, but it's really cheap for you, right? And you simply cannot reach an agreement there, because it's in everybody's self-interest not to reach an agreement that binds themselves, right? It's in our interest to have an agreement that binds the other guys, but not ourselves. So fortunately, the Copenhagen Conference of the Parties in 2009 collapsed quite dramatically. The forecast is that we will see similar things happening in Glasgow over the next couple of weeks. They were replaced in Lima in 2014 by intended nationally determined contributions, where instead of legally binding targets, we now have promises and aspirations. Now you may say, well, that is weak, and that is true, but it's the best you can do. And this is the way we we provide other international public goods. So if there's a pandemic somewhere, or a threat of a pandemic somewhere, what do? We organize an international jamboree, and then we go around with a begging bowl and say, please, countries, can you contribute something? Because if you don't, this pandemic will spread. Obviously, we did not do this in time with COVID, but we did it with Ebola and things like that. And then Japan will provide money, and Germany will send doctors, and Pakistan will send nurses, right? And then you have a way of containing the problem. Similarly, if you need a peacekeeping force, what do? You organize an international jamboree and you go around with a begging bowl, and Japan will give money and the US will give logistical support and Nigeria will send soldiers, right? And that is how we create peacekeeping forces, which is a public good as well, a global public good. But it's all based on the free will of countries. Nobody is forced to do it. It's essentially pledge and review. And then review, later on you come back and you say, well, did we do enough? Well, the answer is always no, but we did more than nothing, right? And since Lima 2014, the international climate negotiations are sort of in the same style. Lima is in Peru, that's a poor country, so this was confirmed a year later in Paris. So now we have a big, strong country with its name on the treaty, right? But it's really the Lima Treaty that we are talking about. So that is, and I'll show you some of the text in a minute. The second reason why climate is so hard to solve is because it's a wicked problem. And again, popular language is different from academic language. The term wicked actually means something, is actually jargon in political science. And a problem is considered wicked if a number of conditions are met. One is that there's no stopping rule. You can't just solve the problem, it just keeps coming back. There is no black and white, solutions are better or worse. Not good or bad, they're better or worse. And actions have irreversible consequences. And all these three things are true for climate policy. It's terrible jargon, right? Not just because there's also a popular meaning and a colloquial meaning to the word wicked, right? And the popular and the colloquial and the dictionary meaning of the word wicked are, of course, also opposite, right? But also because illiteracy among 6-year-olds is a wicked problem. Because you get a class of 6-year-olds who can't read and write, and you work hard for a year with them to teach them how to write their name and read simple books, and then you go back the next year and there's another crop of 6-year-olds who can't read or write, and you can start all over again, right? So illiteracy among 6-year-olds is a wicked problem. We don't see it as a wicked problem at all. We see it as a thing to be solved. And the way we solve primary education is essentially by building institutions to do so. We don't have an annual debate in Parliament. Should we train this year's crop of 6-year-olds to read and write? No, we don't have that discussion anymore. We have discussions about should we increase teacher salaries by 1% or by 2% per year. That is what a political discussion is about. We've built an institution to not solve the problem, because as long as there's children, there will be illiterate children, but manage the problem and contain the problem and solve the problem at least for every cohort, for most of each cohort of students, right? So you start by building a broad consensus on the direction of travel, and this discussion actually took place in the end of the 19th century about universal primary education, and then you build institutions to keep at it, right? And that is exactly what the Paris Agreement or the Lima Agreement did, right? Article 4.2 says each party shall prepare, communicate and maintain successive nationally determined contributions that it intends to achieve. Parties shall pursue domestic mitigation measures with the aim of achieving the objectives of such contributions. Each party's successive nationally determined contribution will represent a progression beyond the party's then current nationally determined contribution. A party may at any time adjust its existing nationally determined contribution with a view to enhancing its level of ambition. So essentially this says, thou shalt have a climate policy. And that is the only obligation that the Paris Agreement places on countries. It also says that once you have a climate policy, you can do only one thing with it, and that is to make it more ambitious. You cannot weaken its ambition, right? That is the only obligation that we have placed on ourselves. And it's up to Parliament or the dictator or whoever makes decisions to sort this out. It's out of the hand of the United Nations. And then every few years, and the first time will be in 2023, there will be a global stock take to say, have we done enough? And if not, can you please do more, right? But the question, have you done enough and have you met your commitments, will be done in a way, compliance, will be done in a manner that is transparent, non-adversarial and non-punitive. So if the UK promised to cut its emissions by 10% and it won't meet that target, actually the UK has promised a bit more and it won't meet that target, then there will be a committee in the United Nations, and that committee will ask, dear Boris, can you please explain? But that will be done in a transparent way, which is always good. It will be done in a non-adversarial way. So you cannot say, Boris, you're a bit of a fool, aren't you? That is the sort of question that would not be allowed in this committee. You can just ask them to politely explain. And it will be non-punitive. So no sanctions applied. So it's very, very weak, right? It's very weak. And then, of course, Article 28 of the Paris Agreement, the party may withdraw from its agreement, from the agreement at any time, which is, of course, what Donald Trump did. Now, I never understood this because the Paris Agreement is so weak. Why would you want to withdraw? And I would think that Trump being Trump, he could just have claimed that his climate plan was better than Obama's climate plan, right? Because everything he did was better than what Obama did. So that would have been a more logical course of action for President Trump, but not one that he followed. Final chapter. Politics around climate are in a bad equilibrium. With unrealistic expectations and a focus on anything but emission reduction. So I showed you some of the text of the Paris Agreement and said it's pretty weak. But there's another part of the Paris Agreement, Article 2, and that, and I alluded to this before, aims to hold the increase in the global average temperature to well below 2 degrees above pre-industrial levels and pursue efforts to limit the temperature increase to 1.5 above pre-industrial levels. And I also said, well, this is going to be tough. This is going to be very expensive, and this is going to be almost politically impossible to pull off. So why was this stuck in there? The reason, I think, is that this was a way to placate the environmentalists. That the Paris Agreement is pretty weak in terms of its ambitions, in terms of its enforcement and everything. Essentially, it says, thou shalt have a climate policy, and if you don't meet your promises, then we will write it up in a report. That's essentially what the Paris Agreement is. And of course, a lot of people were very disappointed with this outcome, and therefore they agreed on this target that is and looks very ambitious, but there's nothing to back it up. This is a paper tiger, and it allowed the environmentalists to claim success in Paris. At the same time, the people who were not so keen on climate policy could silently claim success because nothing had really been agreed, right? So this is the typical diplomatic thoughts that everybody in the room gets something. I don't have a whole lot of time left, so I will go through this fairly quickly. We are nowhere near meeting this. So in black, you're looking at historical emissions. In red, you're looking at what would have happened without the Paris Agreement, or what were the plans before Paris. And then in orange here, you're looking at what would happen if we meet our current policies, if those are actually do what they say on paper. These are emission pledges that are not backed up by policy yet. And in blue, this is what we need to do to meet the target, right? So we're not anywhere near what we need to do. And the fear for Glasgow, apart from the chaos, apart from the pandemic, apart from the clowns in charge, is that the world will be forced to realize that, yeah, in Paris we agreed to do this, the blue one, but we're really only doing the orange, and it's China's fault. No, it's India's fault. No, it's the Americans who did it, right? That will be Glasgow. Now, how did we get here, right? Why do we agree on things that we should not, that we cannot do? There's all sorts of reasons why the climate debate is in such a mess. I mentioned a couple of reasons already. There's also fallacies in reasoning, and there's one that I will highlight. Climate change is often called unprecedented, and the reason for that you see here. This is the CO2 concentration over the last 800,000 years. We are currently here, and what you see is that this is completely and totally unprecedented over the history of our species. And some people say, well, we've never been here before, so we must do something about this, right? And Eric Holthaus says this here: we have officially crossed over 418 parts per million by volume, the highest atmospheric carbon dioxide levels in millions of years, before the pyramids, before the ice ages, before modern humans existed. Humanity has never experienced our planet like this. All true, right? And then his conclusion: we are in a climate emergency. This is what philosophers call the is-ought fallacy, or the naturalist fallacy. Is-ought is David Hume, naturalist is George Moore. But it goes back to Friedrich Schiller, right? This is a romantic notion. Friedrich Schiller is the guy who wrote the lyrics to Alle Menschen werden Brüder, right? The anthem of the European Union. And Schiller argued that God has created the world, and God is good, and therefore the world that God has given us is the best world possible. And any change that we would make to this world is bad, therefore. Right? And that is the reasoning that Eric Holthaus is also doing. We've never been here before, so this is bad. Well, we've never schooled children to the levels we have before. We've never had so many people living in democratic countries under democratic governments as ever before, and so on and so forth, right? We've never, I mean, there's a lot of girls in the room. Women's rights aren't what they should be, but they're a lot better than in your mother's time or in your grandmother's time, right? But according to people like Eric Holthaus, this is bad. Change is bad, right? Change can only be for the bad. This is just a complete bogus reason. The second thing that people get wrong is the role of science. Now, in the olden times, the church used to offer a theory of how the world works, Genesis and all those things. This is how the world was created, or the Quran has similar stories, or if you're a Hindu, there's similar stories of how the world came to be and why things are as they are. So that is one thing that religions used to do. Another thing that a religion does is it tells you how to behave, how to be a good person. Right? It gives you how the world works and how to be a good person. Now, since the Enlightenment, we have separated the two. We have separated the question of how the world works We've taken it away from the church authorities and we've given it to universities and places like that. Universities don't teach you what is good or bad, and if you go study, even if you go study philosophy and ethics, well, they'll tell you all the conundrums that are out there, but they won't tell you how to be a good person. The problem with science is that in the olden times, with the Enlightenment, a clever human could understand all of science. Newton understood basically everything we could understand. That is no longer possible. We now know so much that every expert is an expert in a discipline. And this realization has gotten lost on people. Here is Scott Lennon. Scientists have landed a spacecraft on a proverbial dime on a planet 40 million miles away. This is Mars, and rotates at 241 meters per second, still Mars. Think I'm going to trust them on this climate change stuff. Like what? Because rocket scientists are clever, climate scientists are clever, as if they are the same person. Neil deGrasse Tyson, similar story. We've done this on Mars, must be true about climate change. No, completely different things. We made a photograph of a black hole. These are completely different disciplines, right? And this is just wrong, right? Another problem nowadays is that facts and morals derive from different authorities. And some people find it confusing, and some people attach moral authority to science. Because you are so clever, professor, you must be wise. Because you are so smart, professor, you must be good. Now, you guys have just arrived at university. After 3 years, you will realize that none of these things is true. The fact that somebody is very clever and very smart and maybe at the top of the world in a small subdiscipline does not make them a good person, does not make them a wise person, does not make them a nice person, and doesn't necessarily make them a clever person outside their very narrow specialization. Right? But people out there sort of crave for the old way in it was, that there is one authority. And of course some academics enjoy this particular status. Some academics actually like it when people look up to them and think that they are wise and nice because they are so smart. Not true. And this is the current Director General of the United Nations, who says that climate action is urgent, the science demands it. Science demands nothing of you. Here's another one. Yasemin Ansari, I'm 100% in for bold and unprecedented action because that's what the science demands. Closer to home, Caroline Lucas, urgent climate action at the scale and speed the science demands. Eric Holthaus again, same story. The Guardian, same story. AFP News, Greta Thunberg actually, same story. The science demands action. This is just wrong. Here actually a cat says the same thing with just as valid a reasoning, right, and just as much authority. If you're on the beach and you see that the water is retreating rapidly, then science tells you that a tsunami is coming. Science does not tell you to run for the hills. Science does tell you that if you run for the hills, you increase your chance of survival dramatically. But science doesn't tell you to run for the hills. It's your survival instinct that tells you to run for the hills. Science demands nothing. Science just tells you what will happen if you do or don't run in this situation, or whether or not a tsunami is likely. The same is true for climate. Science tells you if you put more CO2 in the atmosphere, then the planet will warm. Science may tell you what the implications of that warming might be. Science does not tell you how to spend your money on greenhouse gas emission reduction. Right? And actually, this sort of reasoning, this sort of argument, absolves politicians from the choices that they make. They hide behind others. It's no longer the responsibility of the decision maker to make decisions, but it is hidden. The decision maker, the politician, is hiding behind somebody else. And this has implications that I'll come back in a minute. I argue that the best way to do climate policy is through a carbon tax, a uniform carbon tax, and nothing but a carbon tax. The problem with that is that this doesn't solve any bureaucrats' problems. Because a carbon tax is an excise on food and energy. We have excises already. So the only thing you need is somebody in the treasury to calculate what the new excise would be, and then it rolls out and that's it. This is not the way to create jobs for your mates. This is not the way to increase your budget if you're a civil servant. What we have seen over the last 30 years is a rapidly expanding climate bureaucracy. We don't have numbers for this. We do have numbers on how much money is spent on those international negotiations. And by now, the annual spend is somewhere between $100 and $150 million per year. And this is just for the international negotiations, right? This is a vast investment money that could be spent on other things. Now, what I've said is that these climate negotiations haven't done a whole lot in terms of reducing emissions, but they have done a whole lot in producing all sorts of rules and regulations and reporting requirements and study requirements and so on and so forth. This is a huge industry by now. That may be the reason why it is this way, right? I talked about apocalypse, right? That environmentalists like to convince people of the old stories, and that is the reason why they phrase it like this. Another thing that the environmental movement offers is a tribe for you to belong to, and a way for you to feel morally superior to people who don't drive a Lexus, right? Nothing to do with climate. And then, of course, all sorts of other good causes, being it racism, being it sexism, be it human rights, be it capitalism or anti-capitalism. A lot of the activists in other fields are sort of looking jealously at climate and say, well, everybody's talking about climate, but I think that racism is important too. And the best way of getting attention for my good cause, racism or anti-racism rather, racism is not a good cause, it's a bad cause. The best way to get attention for my good cause, anti-racism, is to pretend that climate is a racist issue, right? And that just complicates the debate. And of course, people have also jumped on this from the anti-capitalist movement. Now, if you are the sort of person who is a sexist or a racist, and you see this, and you say, well, if climate change is racist, then I like climate change, right? Or if you the sort of person who likes capitalism, and climate policy is phrased or framed in an anti-capitalist setting, then you think, maybe climate change is not so bad. Or if you are the sort of person who is all for sovereignty of countries, and you've seen that through climate policy a lot of sovereignty was transferred from Westminster to Brussels, you may say, climate change must be bad because I don't like the implications of this. Now, you can then go on telly and sort of argue your case. But then the opposite, you have a debate with Caroline Lucas, and she says the science demands it. And then you can have a long philosophical debate about whether or not science ever demands anything. But by that time you have lost your audience, right? If you have a 10-second clip on YouTube or on TikTok or on the BBC, your best bet is to attack the science, because the environmentalists all phrase this as it's a scientific imperative. Your best bet of getting your anti-tax or anti-women policy on the table is to say the science is wrong, right? That is what you can do in a 10-second clip. So a lot of the attacks on climate science are inspired by other reasons than attacks on climate science, because climate science is actually pretty sound, by ulterior motivations, but it's also invited in by politicians and by the environmental movement who phrase this as a scientific issue. Even if it's not, right? And there's currently a couple of clips, a great many clips floating around just how uninformed is the polite word some of these climate activists are, right? So last week we saw this clip of one of the people, a medical doctor nonetheless, of Insulate Britain, who had glued herself to the road and claimed that because of climate change we are going to run out of oxygen. She's a medical doctor. Where did she get this, right? Today in Dutch, and most of you guys don't speak Dutch, there was a clip on YouTube of a journalist interviewing another bunch of climate protesters, asking them what is the difference between CO2 and carbon dioxide. And they seriously answered the question. And they seriously started making up reasons how the chemical formula is different than the English word for the same thing. Right? A lot of these environmentalists are actually not very scientifically literate. But that is how they frame their problems, so the best way is just attacking them, right? Attacking the science. And that, of course, completely polarizes the debate. So, to wrap up, 1 hour, 43 minutes later, climate change is not an existential threat, but it is a problem that can and should be solved. Unfortunately, the climate policy debate is stuck in exaggeration, polarization, and false promises, and we really need to get to a more rational debate. That's all I wanted to say.